This lesson's on graphing exponential decay functions. So we've already looked at exponential growth, now we're looking at decay. So it's going to be a little different. We still have y equals a times b to the x, b raised to the x power. And like I said, it's similar to the growth function. But here, even if a is greater than 0, b is between 0 and 1. So it's going to be like a fraction or a decimal less than 1. So b is what's called our decay factor. So instead of our growth factor, we have a decay factor here when it's between 0 and 1. So here's the most basic example. Our parent function f of x equals b to the x, where b is between 0 and 1. We have the curve here. So where x equals 0, we have b to the 0 is just going to be 1, so we have the coordinate 0, 1. And over here, if x equals 1, it's just going to be b to the 1, so we're just going to end up with b. So those are our two main points when making a sketch of this graph. And notice that in exponential decay, it falls to the right, so it's just getting smaller and smaller and smaller, approaching this x-axis down here, but never quite touching it. And so the x-axis is kind of like an asymptote. The domain here would be all reals, because we can go all the way that way or all the way this way to the right. And the range, if you notice, it never goes below the x-axis, so it never goes below where y is equal to 0. So y has to be greater than 0. Here's a quick graph example. We've got y equals 1/2 to the x, so b is 1/2. We don't have an a value right here. A way to make this a little easier is to just make a table first. That way you can sketch a more accurate graph. So we've got our x and y values. I did -2 to 2. It's always a pretty safe range to go to when you're looking at basic functions. So with -2, just put that in here. Ended up with 4. Did the rest for the rest of them. So we've got -2, 4, and -1, 2, 0 and 1, 1, 1/2, and 2, and 1/4. And notice the further you get over here, like going right on the x-axis, the smaller the output's going to be. So it's just going to keep getting smaller and smaller and smaller. Just actually, it's going to get smaller by 1/2 each time. If you notice, we've got 4, 2, 1, divided by 2 is 1/2, divided by 2 is 1/4. Okay, here's a few others with some not quite as detailed sketches, but I'm just taking a quick look. We've got y equals 2 times 1/4 to the x. So the main 2 points we're going to be worried about when we're making a sketch are 0 and 1 for the x coordinates. So if we put in 0 to the function, we're going to come out with 2, and that's what we have right here. And if we put in 1, we're just going to come out, well, we're going to have 1/4 to the first times 2, which is 1/2. That's what we're going to get. So that 2 is kind of stretch this exponential function a little bit. And here we have a -3 out in front, so that negative is going to flip this graph like that. And we have b is our b value is 2/5, and it's raised to the x. So again, if we look at 0 and 1, we're going to get -3 and -6/5. So we'll just plot that on here. And in this one, it keeps coming closer and closer up to the x-axis, but never quite reaches it.